All right, Algebra 2A folks, here we go. We're going to finish up this quiz on logarithms version 1. We're going to do the last 5 problems here. So let's scroll down to those, get those last 5, if I can find it here. There we go. Okay, so 13 through 16, our instructions here say we're going to solve each equation for the variable. Round final answers, we have rounding instructions. We'll get there when we get a final answer. And then, of course, check our answers. So if you've watched the video or you know how to do 11 and 12, essentially when we check our answers, we're going to do like we did in 11 and 12. We just have some work to get to a value first, to get x equals 5 or y equals 4 before we can check. So here we go, 13 through 16. So sometimes, like number 13 here, you might just know that, for example, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. You just keep multiplying by another 2. And so if eventually you're going to hit 64 here. 2 to the fifth power is 32, and 2 to the sixth power would give you 64. So sometimes just by, whoops, that is not my final answer, but just by kind of having number sense, it's almost like saying like, a plus 3 equals 8, and you go, oh, I just know it's 5. So 6 would be the answer. Let me box in the 6. But if you didn't know that, or if it wasn't nice numbers like that, how would you come up with the 6? So I'll take you through that. First of all, we can check that. Let's go ahead and do the check step. Let me make sure 2 to the 6th power equals 64. Let's bring up the calculator there. I'm pretty sure that's what it is. All right, so 2 to the power of 6 equals 64. Okay, so that is correct. But again, if we didn't know that, or if the numbers weren't as nice, how would we get that? So what we could do is we could rewrite it in logarithmic form. So if you either watch the video on 1 through 10, or if you know how to switch between exponential and logarithmic form would look like this. We would have base 2 would be our base. That's supposed to be a g there. Log base 2. And then remember the exponent and the other number are going to switch. So this would be log base 2 of 64 equals x. So that would be one way to express the value of x, log base 2 of 64. But most people, that's not going to mean much to. So then what you can do, and I'm going to put this up at the top here, I don't know if I'm going to have space to write out the formula, but it's something you should have maybe in your notes or in a textbook packet or somewhere. It's called the change of base formula. Change of base formula. So basically, most calculators have base 10 or base e, the natural logarithm. Most calculators, in my experience, don't have base 2. So what you can do is you can either do the common logarithm of 64 over the common logarithm of 2. So that's log base 10, and we'll try that on the calculator. Excuse me. So if we do here, I think I have to do the number first, then tell it to do the logarithm. So 64 is logarithm, but I'm not done yet, and we're going to divide that by 2's common logarithm. So I see it up there, and if I ask what does that equal, it gives me exactly 6. So there you go. So that's how you could calculate it if you didn't know. You also could do, so let me fill this in. So that would give you a 6. You could also do the natural logarithm if you prefer. You could say the natural logarithm, base e of 64 over, you got to use the same base logarithm, natural logarithm of 2. Let's try that one real quick. It should give us the same result. So if we do 64's natural logarithm, there's the natural logarithm there, but we divide by 2's natural logarithm and we get 6 again. So yeah, that change of base formula, it can be real handy. But all right, let's move on to number 14. This is one I don't know off the top of my head. 2 to what power gives you 100? Going off of number 13, 2 to the 6th is 64. If you did 2 to the 7th power, you'd be doubling 64. It's 128. So I go, all right, so here we're going to be between 6 and 7. Because 2 to the 6th is 64, and 2 to the 7th is 128, and we're looking for a number that's in between 64 and 128. So stands to reason that our value is going to be between 6 and 7. But let's see if we can be a little more accurate here. So again, what I'm going to do is I'm going to rewrite this in log form. And remember, if you want to rewrite it as 2 to the y equals 100, if that's easier for you. But here we'd have, it'd be log, 2 would be our base again, and then the 100 and the y are going to switch places. So we'd have 100 there and equals y. And so again, here, technically, this is an answer. This is an answer for y. Log base 2 of 100 is the value of y. But most people aren't going to make sense of that. So, and if my calculator doesn't have base 2, this is where we're going to do that change of base formula again. So we could do the common logarithm of 100 and divide by the common logarithm of 2, or we could do the natural logarithm of 100 divided by the natural logarithm of 2, and I'll try it both ways here, but we should get the same result, and we already know it's going to be 6 point something. So let's try it out. If we do 100's common logarithm, that's 2, because 10 to the second power is 100, but we're dividing that by 2's common logarithm, and we get, all right, let's see, 6.6438, so I'll write down a few digits, 6.6438. Oops, okay, 6.6438 keeps going. Let's double check if we do that with the natural logarithms. So if we do 100's natural logarithm divided by 2's natural logarithm, I should get the same result here. And there we go, 6.6438, etc. So now comes the rounding. So now we're rounding to the nearest hundredth, which is the decimal point and 2 more digits. We're looking at the 4. We got the 3 next to it. That's 4 more, let it rest. So here y is going to be approximately 6.64. Okay. Before I box that in, let's check here. Let's see if we do 2 to the power of 6.64. We're supposed to get close to 100. So let's try that out. So 2 to the power of 6.64. And we get 99.7. All right, so pretty good. If we tried like 2 to the power of 6.63, we're not going to get quite as close. We're a little bit further away. Last time I think it was 99.7. Now it's 99.0. What if we tried 2 to the power of 6.65? We're over 100. In fact, we're further away from 100 than we used 6.64. So let me just do it one more time here. 2 to the power of 6.64 was 99.73 something. So it's pretty close. Again, we're not using an exact value. So it's approximately 100. So 6.64, that is my final answer there. All right, so continuing on here. E to the power of m, so this is one where if you recognize that number e, 2.7 whatever it is, oops, and there it is, where'd my cursor go? So this is, yeah, I'd probably just start doing log form here. And so, all right, so my base is e, log base e, switch the m and the 64, log base e of 64 equals m. And this is when I go, well, hey, log base e is the natural logarithm. So this is just the natural logarithm of 64 equals m. And again, that's an exact answer, technically. But if we want to get a better idea of like, what is that approximately? So I just have to do the natural logarithm, the ln of 64, 4.15888. And then we'll round here. So 4.15, I'll just do that. 88, okay, whatever. All right, but now we're rounding to the nearest hundredth. We got a 5 in the hundredths place with an 8 next door. That's going to round us to 4.16. So 4.16 is the approximate value of m. And let's check that real quick. Let's do e to the power of 4.16. So let me find it here. Where's my e button on this calculator? There it is. So we got e. So there's e, 2.7182818. Doesn't keep repeating, but we're going to go to the power of 4.16, we said. And so we're hoping to get about 64. And again, we get close to it, 64.07, whatever. Looks good to me. So that's our check step. Ooh, I don't know if I labeled my check step last time, but check. So if we do e to the power of 4.16, and what did we get? We got, whoops, what did we get there? 64.071 Kept going. But I go, yeah, so that's approximately 64. So unless it's a rounding error, I feel good about that answer. So we'll box that in. All right, a couple more. Number 16, 10 to the power of n equals 5. So this is kind of like the check step, if you watch that video, where a lot of people might just go, oh, it's a half, right? Half of 10, 10 times a half. And I go, but this is not multiplication. This is not 10 times m. So let's just go straight to the log form here, the logarithmic form. We'd have log base 10. That's my base, and we're going to switch n and the 5. So log base 10 of 5 equals n. And this is then log base 10. That's the common logarithm. So I can just, on the calculator, I can just do the log button. Log of 5 equals n. And again, this is an exact answer, but let's see what the calculator says when we do the common logarithm of 5. Oops, where's my calculator? There it is. Common logarithm of 5. So 5's common logarithm, 0.6989. I'll just write that down, 0.6989, and then we'll round it. So then to the nearest hundredth, we've got a 9 in the hundredths place with an 8 next to. Oh, this is a good one. So 69 will round up to 70. So 0.69 will round up to 0.70. That's our approximate value of n. And this one, I'm going to skip writing down. I've already boxed it, but I'm going to skip writing this down. So it's 10 to that power. So let's do 10 to the power of 0.70. We're hoping to get 5. And we get pretty close. All right, so I'm going to skip writing down the check step on that. But I'm doing it on the calculator, you can see. But there you go. So using logarithms to solve these equations when the exponent is a variable. Okay. All right, so one more, and it's a story problem. And it's a little more complicated. So let's see what we can do with the story problem. If you haven't read it yet, it says the population of a city is modeled by this equation, where P is the population in millions of people after T months. After how many months will the population reach 7 million people? And then we have rounding instructions here. So, all right. So first thing we should be able to do, even if you're still confused about these logarithms, you should be able to recognize where it says P is the population in millions of people, and then we have the population, we want that to reach 7 million people. So notice that we already have millions covered for, so I don't have to be like, all right, let's do 7 million, a 7 with 6 zeros. Like, no, the million is included. We're just going to use the 7. So our population P equals 7. So that's going to equal then, filling in for the rest of the equation, 3.5 times 1.006 to the power of t. All right. So that's just putting in the value into the equation. Hopefully we're okay with that. But now we're going to try to solve this. So before we try to throw in any logarithms there, I'm going to solve for just the base and the exponent. So solve for the base to the exponent. So that means this part right here. I want to say what is 1.006 to the power of t? What is that equal to? So that means I want to cancel the 3.5. 3.5 is being multiplied, so divide by 3.5 would cancel that. Balance your equation, and hey, that's going to give us exactly 2 on the left side there. So this would be 2 equals 1.006 to the power of t. Now this looks like the previous 4 that we've done. So I encourage you, if you haven't, pause the video, try the rest on your own. But here we go. So I'm going to change this to log form. This would be log base 1.006. We're switching the 2 and the t when we put the logarithm on there. So log base 1.006 of 2 equals t. That's an exact answer. But if we do the change of base, formula, unless you have a fancy calculator that you can put in base 1.006, we could do either the common logarithm of 2 over the common logarithm of 1.006. We could do the natural logarithm of 2, as long as we also do the natural logarithm of 1.006, whatever we got there. I'll try it both ways here. I'll do it real quick both ways, and we'll see. So let's see what we're doing. So it's 2, if we do the common logarithm of 2 and we divide by 1.006's common logarithm, we get 115.87, all right, 115.87 roughly. If we do 2 natural logarithm divided by 1.006 natural logarithm, we get the same thing, 115.87 something. All right, just a couple things left with that, and one is to round. We're supposed to round here to the nearest whole number, so that means no fractions, no decimals. So we're between 115 and 116, but we're closer to 116. That would be 116 months. A lot of students will say, like, well, how many years is that? And that's like, well, we could figure that out, but it's not asking us. The only other thing I'm going to do is I'm going to check the original equation. Remember, the million's already part of this, so I'm hoping to just get 7. But if we do, got to bring back the 3.5. 3.5 multiplied by 1.006 to the power of 116. I'm actually expecting this to be a little bit more than 7 because we rounded up. But let's see, what do we get here? 7.005, all right, so that'd be millions of people. So it looks good. So, all right, there you go. So that's our quiz. That was a little bit of a longer video, but thanks for sticking through it with me. But yeah, hopefully that helps, and we'll see you in the next video.